In this video, we will show the chemistry of atmosphere and water. When Earth formed 4.6 billion years ago from a hot mixture of gases and solids, it had almost no atmosphere. The surface was molten as Earth cooled, an atmosphere formed mainly from gases freed from volcanoes. It includes hydrogen, sulfide, methane, and 10 to 200 times as much carbon dioxide as today's atmosphere. After about half a billion years, Earth's surface cooled and solidified enough for water to collect on it. Complex chemical reactions in the young oceans transformed carbon-containing molecules into simple, living cells that did not need oxygen to live. Instead, they made energy out of sulfur and other elements. 2.7 billion years ago, flourished green microscopic organisms called cyanobacteria flourished in Earth's oceans. They made gaseous or free oxygen from carbon dioxide, water, and sunlight, the process called photosynthesis. For a long time, the oxygen produced did not build up in the atmosphere, since it was taken up by rock as recorded in banded iron formations and continental red beds. The oxidation of the mantle rocks may have played an important role in the rise of oxygen. It has been hypothesized that change from predominantly submarine to subaerial volcanoes may have also led to a reduction in volcanic emission of reduced gases. Once oxygen had been produced, ultraviolet light splits the molecules, producing the ozone UV shield as a byproduct. Only at this point did light move out of the oceans and respiration involved.
According to Methane Plus, air pollution is a mixture of solid particles and gases in the air. Car emissions, chemical from factories, dust, pollen, and mold spores may be suspended as particles. Ozone gas is a major part of air pollution in the cities. When ozone forms air pollution, it's also called smoke. Some air pollutants are poisonous. Inhaling them can increase the chance you'll have health problems. People with heart or lung disease, older adults, and children are at greater risk from air pollution. Air pollution isn't just outside. The air inside the buildings can be also polluted and affect your health.
Let's go up in the air and see for ourselves how our atmosphere doing.
Carbon monoxide came from vehicle exhaust and some industrial activities. Effect on human health. Increased level of carbon monoxide reduce the amount of oxygen carried by hemoglobin around the body in red blood cells. The result is that vital organs such as brain, nervous tissues, and the heart do not receive enough oxygen to work properly. Carbon dioxide came from burning of fossil fuels. Includes petrol and metal refining, electricity generator from coal-fired power station, other manufacturing industries of food processing. The effect on humans is increased likelihood of respiratory problem. Nitrogen dioxide inflames the lining of the lungs and it can reduce immunity to lung infection. This can cause problems such as wheezing, coughing, cold, flu, and bronchitis. Ozone came from motor vehicle exhaust, oil refining, printing, petrochemical, lawn mowing, aviation, bushfires, and burning off. The effect on human is ozone can irritate the lining of the nose, airway, and lungs. People who are exposed to enough ozone might feel some pain in their ears, eyes, nose, and their throat, and they may start to cough. Sulfur dioxide. 99% of sulfur dioxide in air is from human activity, such as industrial activity that processes materials that contain sulfur, like electricity from coal, oil or gas that contains sulfur. Sulfur dioxide affects human health when it is breathed in. It irritates the nose, throat, and airways to cause coughing, wheezing, shortness of breath, or a tight feeling around the chest.
According to National Geographic, global warming describes the current rise in the average temperature of Earth's air and oceans. It is what causes the set of changes to the Earth's climate or long-term weather patterns that varies from place to place. Global warming is often described as the most recent example of climate change. Greenhouse effect is described as the trapping of the sun's warmth in the planet's lower atmosphere due to the greater transparency of the atmosphere to visible radiation from sun than to infrared radiation emitted from the planet's surface. The gases that trap heat in the atmosphere are called greenhouse gases. Greenhouse gases includes water vapor, carbon dioxide, methane, nitrous oxide, ozone, and some artificial chemicals such as chlorofluorocarbons.
The chemistry of water. Are you thirsty? We'll take a look first on our friend water. Water is a chemical compound consisting of two hydrogen atoms and one oxygen atom. The name water typically refers to the liquid state of the H2O.
In its liquid form, water is transparent and nearly colorless. Pure water is an electrical insulator. Water is an excellent solvent because of its polarity.
We drink water almost every day, but do you know what type of water you're drinking?
Different types of water. Tap water. Tap water is the water that you get directly from the faucet. It may or may not be suited for drinking purposes. It is widely used for household chores such as cleaning, cooking, gardening, and washing clothes. Mineral water. This is the water that naturally contains mineral. The essential minerals give it reputation of health drinking water. Spring water. Spring water is a water that comes from a spring as opposed to a river, lake, or a stream. The quality of water from spring can vary due to factors such as the type of rock which the water is in contact with. Well water. When it rains, water trails down and travels through the inner crevice of the soil beneath the ground to form underground lake, which is what people collect and use. Purified water. A purified water is the water which, after deriving from its source, has underneath purification treatment in a plant. The act of purifying entails removing all bacteria, making it suitable to drinking and other purposes. Distilled water. Distilled water or demineralized water is one where the water has been subjected to a treatment that removes all its mineral and salt by process of reverse osmosis and distillation. It is absolutely pure form of water but is not typically recommended for drink. Sparkling water. It's the water that has undergone carbonization, which makes your water fizzy just like your sodas. It may be spring water, purified water, or even mineral water.
But wait a minute, have you ever stopped to think whether or not your water is pure? Here's a list of contaminants that could be in your water. Biological contaminants. These include organisms that live in water, like bacteria, parasites, viruses, and protozoan. Most of them are unable to be observed by your naked eye. Chemical contaminants. This includes compounds or elements found in water, like metals, salts, toxins, pesticides, bleach, and more. It can either be man-made or naturally occurring. These contaminants are extremely hazardous to a man's health. Physical contaminants. These changes the physical properties or appearance of water. It includes sediment and other organic matter. Radiological contaminants. Unstable chemical elements with an unbalanced amount of neutrons or protons can cause a radiological contamination like uranium, plutonium, or cesium. Radiation is incredibly hazardous to your health. But no need to worry about those pesky organisms. There are already treatments and processes to make sure that the water that we drink is potable. There are usually 4 steps in processing water in a water treatment plant. Coagulation and flocculation. Coagulation and flocculation are often the first steps in water treatment. Chemicals with a positive charge are added to the water. The positive charge of these chemicals neutralizes the negative charge of dirt and other dissolved particles in the water. When this occurs, the particles bind with the chemicals and form larger particles called flow. Sedimentation. During sedimentation, flux settles to the bottom of the water supply due to its weight. This settling process is called sedimentation. Filtration. Once the flux has settled to the bottom of the water supply, the clear water on top will pass through filters of varying compositions and pore sizes in order to remove dissolved particles such as dust, parasites, bacteria, viruses, and chemicals. Disinfection. After the water has been filtered, a disinfectant may be added in order to kill any remaining parasites, bacteria, and viruses, and to protect the water from germs when it is piped to homes and businesses.